Hello students, class 9 under CBSE board. Today I will discuss on model evaluation. This chapter is under your part B section, unit 3. This is very important chapter, be serious. The first thing is, what is evaluation? When we create an AI model, we need to check how good it is at doing its job. This checking process is called evaluation, right? Imagine you have built a robot that's supposed to sort fruits into apples and oranges, like as you can see in the right side of picture. How do you know if your robot is doing a good job? You watch it sort and see if it is putting the fruits in the right piles. In the machine learning, evaluation means checking how well our computer programs are performing. Next section is discussed under the why evaluate. There are 4 points. For this reason, the evaluation is required. First point is to see if our model is working. Second point is to compare different models. Third one is to improve our models. Fourth one is to make sure it works on new things. And next section, evaluation techniques. There are main two types of evaluation techniques. One is holdout method and second one is cross validation. Holdout method, under this point there are another two types. One is training set and testing set. Training set means it is used to teach the model. Testing set means it is used to test the model after it is trained. And the second method is cross validation. We split the data into multiple parts and keep rotating the training and testing sets. This helps us test the model thoroughly. Next section is splitting the training set data for evaluation. We usually split the data into training set about 70 to 80% and training set about 20 to 30%. Why split? If we train and test on the same data, the model will just memorize answers. We want it to learn to think, not just remember. Got it? And the next section is accuracy. How often are we right? Accuracy means that the percentage of correct prediction made by the model. This is called accuracy. How can accuracy calculated? This is a very important formula for accuracy. Correct prediction divided by total prediction into 100. For example, if our cat or dog model correctly identify 80 out of 100 pictures, its accuracy is 80 by 100, meaning 80%. Second, error. When do we go wrong? The percentage of wrong predictions. Formula is error 100 minus accuracy. We assume 100 is the total numbers subtracted to accuracy. Next, beyond simple right or wrong, evaluation metrics for classification. Sometimes just knowing the overall accuracy is not enough, especially when dealing with category. We need more detailed ways to see where our models is succeeding and failing. When we do classification, we use a special score that is called matrix. There are 5 types of important metrics. One is confusion, second one is accuracy, third one is precision, fourth one is recall, and fifth one is F1 score. Let's discuss one by one. First one is confusion matrix. Confusion matrix is a tabular format like as report card that shows us exactly how our models performed for each category. For example, the model correctly predicted a cat, that is called true cat. The model incorrectly predicted a dog when it was actually a cat, that is called false dog. And false cat means the model incorrectly predicted a cat when it was actually a dog. And true dog means the model correctly predicted a dog. There are 4 stages: TC, FD, FC and TD. If we say some formula for accuracy, true prediction plus true negative divided by true positive plus true negative plus false positive plus false negative. This is the actual formula for calculating accuracy from the confusion matrix. Next, precision. What is precision? Precision means how many of the positive prediction were actually correct. Precision tells us when the model say cats, how often it is actually a cat. It is about the accuracy of the positive prediction. By calculating the formula true positive divided by true positive plus false positive. Next, recall. Did we catch all the positives? Recall tells us how many actual positive cases were correctly identified. Recall tells us of all the actual cats, how many did our model correctly identify as cats. The formula is for recall true positive divided by true positive plus false negative. Second, next point, F1 score. F1 score is the balance, just like justify, between precision and recall. The F1 score is like a balanced average of precision and recall. It is usual when we want a single number that consider both how often our positive prediction are correct and how well we find all the positive cases. The formula is 2 into precision into recall divided by precision plus recall. Next, why precision recall matter? In the real world, imagine a spam email detector. One is high precision that acts like when it marks as email as spam, it is very likely to be actual spam. And high recall means it catch most of the actual spam emails. Second is ethical concern. Why ethics matter? If an AI system gives wrong result, it can hurt people. Like, for this reason, ethics matter is very important for AI. Real life concern, a healthcare AI missing disease can risk lives. Like, a hiring AI might be biased and reject good candidates. And a facial recognition system might wrongly identify someone. This is all our real life example for ethical concern. What can we do? Use diverse training data, test fairly, be transparent, improve model regularly. Next, in the last section, for today's class is conclusion. We review again. Evaluating our machine learning models is crucial for understanding how well they are performing, identifying areas for improvement, and ensuring they are reliable and fair. So, today's class is over now. If any doubts, be very freely you can give me comments, and I assure that prepare a next class for this your doubt class. So be healthy, be stay well, be connect every time with Policy of Design AI Computer Learning Center and with me, King Karval. Thank you.